Hello, good evening, and welcome back to the chaos that is the fabrication of a stainless steel cat-backed exhaust system for my 2003 Honda Accord Tourer. In the previous episodes, we put together the stainless system from the catalytic converter all the way down, around and along, up to the join just before the lower control arm, as I wanted to add that little extra there for maintainability, so this section can be removed independent of this section and vice versa. In this episode we're going to start on the fabrication of the pie cut section for the new back box, and we're going to do a 90-degree pie cut bend. Hundreds of videos on YouTube that explain this process. This is just to give my little spin on it and take you on the journey of fabricating a pie cut section and doing it in probably 5 to 10 to 20 times the amount of time necessary to explain what's ultimately a very simple process. So let's see how we go. Here we are under the car once again, and the main problem which we're tackling at the moment is how to get from the rear of the main pipe under the lower arm, around the lower arm, up and into the back box up here. Now, two key challenges are clearing the lowermost point of the rear arm in this section here and clearing the rearmost point of the lower arm here. Now this one's not too bad because all we have to do is just jack the car up and get this at its peak extension, and then we can measure what space we need to work with here. But the rearmost point, which is free to extend vertically, we need to be able to clear at all points. So once we know how far this is from the back box, we can get our bend radius for the 90-degree pie, which we're going to do off the back of this here. So what we can do is just quickly project off this and get a measurement using a second tape. Very rudimentary, but there we go. As we can see, we've got about 131, let's call it 130 mil play with. And considering this is going to move ever so slightly, we'll consider that later. So yeah, 130 mil from the back box flange to the rearmost point of the lower arm. Let's see how that impacts our pie. Right, now that we have our design envelope of 130 mil, we can draw that on a page so we can start getting close to defining our pie sections. So let's just draw a line of 130 mil. Let's pop off here so we can mark it. Already we're off to a bit of a ropey start. There we go. And then we want to come off this side as well. So we want to go down here. Right. So we have 130 mil from the lower control arm to the back box. So we have back box, lower control arm, and we are 130 mil is what we have to play with. Right, so now we need to work out, what do we need? The bend radius of our 90-degree pie to come out of the back box and travel down here, down to under the lower control arm and to our main pipe. Physical constraints: the back box relative to the car, facing forward being this way, rearward being that way, can move axially frontwards under physical loading of the car or of the back box, as it's only mounted on rubber mounts, and then further up is flexi pipe, and then that's mounted on up to the exhaust manifold on the engine block, and that can twist quite significantly. So that means we can move forward. The lower control arm can twist and move rearward in the bushes slightly, but it's possible, which means that combined, based to nominal obviously, the worst forward position of the back box and the worst rearward position of the lower control arm gives us a measurement on this line here that shows us our critical envelope that we need to work within. Not in the scope of activity to try and work that out, but we can at least do one step back and just pick a completely arbitrary measurement out of thin air. So 17mm spanner, because there are some 17mm headed bolts on the back box flange. We're at about 3.5 centimeters, so 35mm ish. We're going with ish right now. So 35mm gives us 95 off the back box, 35mm off the lower control arm gives us 35mm off the back, 95mm off the back box, which means we can put that down, and we can say that initially this is our design envelope. So, because that means I can just get the spanner up in and get to the back box flange hopefully without too much hassle. Well, that's a bit of a funky looking 5, isn't it? Right. Also, an apology, the camera loves cutting out and it says movie recording has stopped automatically for one reason or another. So if anyone knows why Canon 600Ds tend to do that, then please let me know. I've had it for quite a long time. I got it just for stills photography, and that's all I've ever used it for. This is a series, it's the first time I've ever used it for video. So I have absolutely no idea what I'm doing. Everything's kind of just set to default, and this keeps happening. Web forums say it could be the bit rate of the card, so for sure these are old SD cards. So one was 30 megabytes per second and the other one was 50, so I've bought a 150 megabyte per second card. Still does it. So another thing I've tried is updating the firmware on the camera itself to the latest version. Unfortunately it still does it. And I've also formatted the cards in the camera itself with a low level format, which I've not done in a very long time. Still not working. So unfortunately, if it gets a bit jumpy, it's because of the camera. What I'm also going to do is, this is going to be a relatively long video. I'm probably just going to speed up a lot of this and play YouTube's finest royalty-free classical music. So that's what you're in for. So stick around for that. If you actually get to the end of this and you actually want the full length, then well, let me know, and I shall put you through the pain of however long this is going to take me to do. Because basically we just want to get to a drawing at the end of our 90-degree pie cut section that we're going to be hopefully within this envelope roughly. Remember, we can move the back box rearward a small amount to get our exhaust tip in, because the position of this, oh, it's lovely and dirty, isn't it? It's still quite favourable. So apologies for knocking the camera. Right, let's get going. One big issue you may spot is I'm measuring in 130 bananas and 95 tubs of peanut butter, so we need to make sure that you know these are millimetres. Right, so let's write a little get out of jail free card, shall we? there we have it. There's a couple of drawings. What I will do is I could go over the important bits in Sharpie, I guess, or I could leave it. Lovely, I've got the Sharpie. I've got the Sharpie on the physical object. So yeah, there we go. Let's make it. Let's see how it turns out. Yeah, this should be entertaining. One of the things I don't get on too well with on this bandsaw is the setting for the cut angle. I've already added a bit of paint here to try and make it a little bit more obvious myself, and obviously put a bit of yellow on the 0 for a bit of flair. But when I'm trying to do half-degree cuts for some of the 4.5 degree pies, or even get it quite bang on 9, because if I want to go 90, then I'm going to need to get that quite accurate. So what I do instead is I'll set it on the blade itself with a protractor, and we'll see how that goes now. Right, let's knock the bandsaw back to 0 for the first cut. So to start, let's get some backing for all you people. Let's get that ready. Let's unlock this, and let's sort this back out again. Right. So, as you can see, we've been cutting at an angle because we've already done some pie cuts. This is a shambles, I tell you. Right, there we go. Let's get it down to origin. Bring ourselves into 0. How does that look? Pretty damn true. Let's go half a degree. There we go. I would say a fraction. We are ready. Put that up, move that out of the way, block us off, let's get cutting. Right, now that we've got the bandsaw at 0 degrees for our first cut, I thought I'd grab a few levels and make sure the workpiece is running where we want it to be. So I've got this one here running the bandsaw, and then these 3 on our stainless tube. And as you can see, we're doing pretty good. Now that we have the bandsaw set to a 0 degree cut, giving us a nice squared off end at 90 degrees on here, we're going to cut our first piece of scrap off. So if I can get in there, which will allow us to mark this. So you'll see why in a bit why we need to mark this, so we can index it 180 degrees each cut. So I've got the apprentice running the dead man switch up here, doing a very good job. So let's get to cutting. There we go, first cut. Let's pick you all back up. Let's see how that went. If you'd focus, please. There we go. So that's pretty spot on. Let's mark it. Quick note as well, the reason I brought the pliers in to hold the top of the cut as it was coming off is as the band gets down about 3/4 of the way and it starts running into a greater amount of metal, the resistance is obviously greater, and it puts a twisting action on this, which causes this to want to kick off over here, which then causes the band to want to kick off this way here. So if I'm holding this and stopping it from twisting, and then putting a little bit of support on the base, it means that we get a nice straight cut, because that's something that you have to deal with this as well. So now we can mark our pipe. Alright, now that we've finished our bandsaw up, and hopefully this isn't too loud or I don't get in the way, I'm just going to tidy the end of this up. Nothing too fancy. Nice. So what we want to do is hope our battery stays, and run a piece of tape around the circumference, mostly concentric. We do want a little bit of overlap. There we go, that's overlap it. There we go. And then what we'll do is we'll grab a rule, wherever one may be living. This. And mark our first point here. Whoa, kind of very well, did it? Right, so you know which side of the line which we're using, so let's show you that quick. Annual focus. There we go. So what we've got is our two sections of masking tape and Sharpie line going across all of them, just 0 and then arrows just to show me which side of the smudge I need to use. And then what we're going to do is take this off, find the halfway, put it back on, and then get our other mark, because we want to have a mark on the opposite side, this one. Yeah. Chuck's back on auto. Burn more of the battery. It's flashing red at me. Hopefully we don't lose anything. And then we want to put this in half between our 2 points. Let's get them to line up. Don't have to worry about muddying our hands too much. There we go. Right. Let's mark our halfway point quick. So that's the point which we're going to come off halfway. Let's find our original marking. There we are. And pop our tape back on there. Run ourselves round. Again, mostly concentric, but we want a little bit of an offset. Here I am again. Our camera conked out at the worst moment, so let's carry on. So we're resetting the tape on the pipe so we can mark our halfway point, which you'll see in a moment. And we need to line ourselves back up again. There we go. So let's mark this out and then show you where we are. Made a mess again. There we go. Right, let's bring this up. Pop your manual. There we put 1 on for no reason whatsoever. There we go. So we are back. We've replaced our 2 pieces of masking tape. They've lined up pretty perfect with the original mark which we drew as well, which is hopefully clear enough on camera. There we go. Look at that, that's a bit nicer, isn't it? And then it's allowed us to draw a halfway point off the bottom. Hopefully you can see the mark. So there. So then we're just going to use this and mark ourselves along the tube, because this will become very important, because for each cut we need to index ourselves 180 degrees, and again through the process you'll see why. I won't explain to you now, it's just better to show you. So let's get back in the bandsaw, let's set ourselves to 9 degrees so we can make some 18 degree pie sections. Let's go. Alright, now that we have done our 0 degree cut, we want to come in, slacken this off, drop this in, get ourselves back on origin, up to 10, sort ourselves back out again, and then move ourselves over to about 9 degrees. So we have 10, 9, there, perfect. Put that up, take this slowly, put that off, let's go. Now that we have the band set to a 9 degree cut and everything is level, we're going to bring this piece in, touch it off on the blade, there. Go, and we're going to measure from the blade to the stop, because that'll move each time you change the angle. 25 millimeters at 9 degree cut, and what we need to do is add on how much we need to cut off, and each time we do that it just gives us a consistent means of measurement. So we worked out before that we need 30 mil on the top of the pie, so 25 plus 30 because it's 55. However, we need to also add in the width of the blade, otherwise we're going to get consistently short cuts. Not too bad at the end of the day. This is still only a kind of by eye thing, because we just needed to remain within our design envelope, not go up to the edge of it, because we won't get any noticeable performance increase. So we just want to remain well within it. We can absorb that, but we can also try and at least do somewhat properly. So we're going to add on 0.5 mil. That's the manufacturer declared width of the blade, and we're going to try and stay on the top end of that. Because it's an old blade, it's going to be ripping as much as it's cutting, so it's just going to have a bit more of an impact on the cut. So we just won't be conservative with our measurement on that, or shall we say we'll be a bit liberal on it. So what we need to do next is move the piece forward 55.5 mil, and if we go to 55 or 56, it's not the worst thing in the world. There we go. Come on, there we go. 55.5, and make sure that that's indexed correctly. We are. And this is our first cut off of a 90 degree corner, so this will be our start or exit. So let's get this on the go.
cutting, like I did, that the pan didn't sound too happy. And this is the manufactured joint. So if we turn the lights off and hope that the camera doesn't auto adjust, and we run a torch on the back side, you can see that the welded joint has unfortunately failed early, because the blades don't look half bad, but if I was to leave this blade in, it would fail hard, and we don't want that. Oh well, alas, it is what it is. It's done over 100 cuts, so can't be too mad, eh?
And there we are, one 90-degree stainless pie cut bend. This is straight off the bandsaw. I haven't deburred it or run it over the belt sander yet, so this is as rough as it gets. As I've probably shown you, the blade is on its way out, so some of these cuts are rougher than they used to be. And I'm just going to change that blade, but that wouldn't have changed too much. All it would have done is just cut a little bit more than I expected. And all that would have done is just reduced the overall bend radius, overall centerline radius of this by reducing the distance between each section of pie. It shouldn't have impacted our actual angle. One thing I can show you is I made the two ends slightly different lengths. So the end that's going to go into the flange here, the gas in this direction, down here we're going into the back box there, and I just wanted to leave enough space for my TIG torch to get in there. I do have some meaty gas lenses that will allow me to run quite a nice stick out to get into an area much tighter than this, but you know, let's just keep it simple, eh, while we can. So if I measure the... You done? Cool. Measure the angle of this. We can see where we got to. Where are we? Again. Cool. Let's bring that up and get it in focus. Where are we? There we are. There we go. So we can see we're running at about 91.5 degrees off this part here. Ooh, there we go. So that's most likely due to a stack up. So I could take you on another autofocus adventure. Cool. Off this edge here. Off this end of it here, just the burrs stacking up has taken us over 90. So when I prep this for welding, we will get back to 90 degrees and we'll have no issues. And just quick check to make sure I haven't completely ruined this. No, we are still well within 130 mil. So that means that the suspension can do whatever it likes and it won't come into contact with this unless there's something very wrong, and this will be the least of my issues at that point. So there we are. I'd call that a success. Welcome back to the bench, and what did we learn today? Well, naffle welding, I'm sorry about that, but we did at least define a design envelope for a part, drew the part, defined used some various calculations to find some key parameters of that part in particular, and then ran it off the bandsaw and then taped it together prior to welding it, which is coming up in the future. So we went from what's ultimately on that page there to this part here, which I think is quite funky when you can just have all the progression from start to finish is always quite satisfying. I will say, just for a bit of fun, I also ran off a second 90-degree pie cut. This time, instead of 30 mil off top width of each pie section, I did one with 25 for two reasons really. One, just for a little bit of extra welding practice to just get in on the tight bits there and see how well it does actually go in the end. and 2, just in case I actually need it for one reason or another. If this does end up clashing with a lower control arm, which I'm 99% confident that it won't, but for the sake of an extra, what was it, probably just an extra 10 minutes of cuts on the bandsaw, and I have all this spare steel, I may as well just run it off, weld it out, just for a bit of fun. The next episode, I will most likely just upload the unedited time lapse just to fill my lounge with my dull monotone voice for my family, so that'll be fantastic. I'm sure they cannot wait for that. On another note, you will, or at least I, was very pleased to note that we did make the wedding in the end. So this is how that went. And due to the what may feel like discontinuity now is, why am I still making parts, and why did you just see a clip of the car successfully, well, not driving, but successfully making noises, all the right noises I'll note. There are a couple of issues which I am addressing. So off in the back corner up here, it got very close to the time before we had to leave. I think it was about 6 hours before we had to leave, and the pie cut sections were still not complete. I was probably about where would I have been? Probably about 150 mil off actually getting them together, and it would have taken a bit more time on the bandsaw to cut some more parts and kind of finesse it all together. But I decided to just use scrap parts, call it there. I was running low on gas, so the gas was already really low anyway, so the welds weren't coming out at great quality. I was running out of time, so I was having to run it super hot, which meant that I was just destroying the properties of the stainless, so that pie cut section is most likely going to rust within the next few years, unfortunately. And the fit and finish is way below the standard which I want. Not only just for visual appearance, the fact that I couldn't purge it due to lacking gas and time, but also because I had to use scrap parts, the exit is kinked off to the side and shoved down slightly, just because I had to use practice and scrap pieces to throw it together. That means that the tip here is still not on the car, and this is of course the final piece in the puzzle, and with this being in my hands, the project is not complete. Once I'm no longer holding this and the car's holding this, we can call this complete. So let's get to that. See you in the next one.